All right, so I wanted to do some more examples about tree diagrams and conditional probabilities because it seems like we're still having a little bit of an issue. So the first thing with tree diagrams is knowing when I need to do it. So the easiest way to tell I need to do a tree diagram is when I have different probabilities based on whether something happens or not. So looking at this problem, the probability you study for a test and get an A is 60%, a B is 30%, and a C or lower is 10%. The probability you do not study for the test and get an A is 50%, that you get a B is 30%, and that you get a C or lower is 20%. 70% of students say they study for the test. So I have two things going on. I have whether or not you studied for the test, and then I have what grade you get. So when I'm doing a tree diagram, I need to think about which goes first. So because my grade is based on whether I studied or not, studying and not studying are going to be my first branches. And then I'm going to put their probabilities. So it says that 70%, so 0.7, study, and then this needs to add to 1, so 1 minus 0.7 is 0.3. That means 30% of students did not study. And then we have three branches coming off of that. We have A, B, and C or lower. So A, B, and C or lower. I'm just using a little arrow. So if I study, my probabilities are 0.6, 0.3, and 0.1. If I don't study, those probabilities change to 0.5, 0.3, and 0.2. So now if I multiply across the branches, I get the intersection. So if I multiply the top branches, this is giving me the probability that I study and get an A. Or I could write this, the probability of study intersection A. I'm finding the intersections here. And so I do that by multiplying. So 0.7 times 0.6 gives me 0.42. That I study and then get a B is 0.7 times 0.3. So that's 0.21. That I study and get a C or lower would be 0.7 times 0.1, so that's 0.07. And then I'm going to do the same thing over here. This is not studying and getting an A is 0.3 times 0.5, so 0.15. Not study and a B, 0.3 times 0.3, so that's 0.09. And not study and C or lower, 0.3 times 0.2, so 0.06. So I really suggest writing out all of those multiplications showing that to make sure that we get full credit. And now I can actually answer some questions. So what is the probability that you get an A? So the probability I get an A means I studied and got an A, or I didn't study and got an A. So I'm going to do 0.42 plus 0.15. So that is 0.57. So there were two possible ways I could get an A, but they couldn't happen at the same time. I either studied or I didn't study. So there's no intersection of those two things. What's the probability you studied given you got an A? So I'm going to rewrite this with my probability notation. So what is the probability I studied, so I was using S for that, given I got an A? So if I use my formula sheet, that means it's looking for the probability of I studied and had an A over the probability of what I was given. So in this case, that was the probability of getting an A. So I need to look at my tree diagram for where I studied and got an A. That would be my first row. That's where I studied, got an A, so that's 0.42 over what's the probability that I got an A either way is 0.57. So I would divide those two to get my decimal. So we could think about some other questions. So we could think about what is the probability that I get a B or a C. So if I think about my formulas, the or is telling me I'm talking about a union. So I want the probability of a B or a C. So from my formula sheet, that would be probability of B plus probability of C minus the probability of B and C. But can I have a B and a C at the same time? No. So I don't need that part. These events are mutually exclusive. They cannot happen at the same time. So that means this probability of them both happening is 0. So then what I can do is go through and add all the spots where I got a B, all the spots where I got a C. So 0.21 plus 0.07 plus 0.09 plus 0.06. That would be giving me the probability of a B or a C. If I still had the probability of an A written, I could have just done 1 minus that because this is the complement. And the last thing I wanted to talk about was to talk about independence. So if I want to know whether the events of RA and studying independent, what I would look for is definition of independence. That's the probability of A. Is that the same as the probability of A given that I studied? Or I could do the other direction. What's the probability I studied? Is that equal to the probability that I studied given I got an A? So the probability that we got an A, we found that earlier, was 0.57. And what's the probability of an A given that I studied? Well, that was actually the first thing they gave me. The probability that I studied for the test, so that's my given I studied, the probability that I get an A is 0.6. So I actually don't need to do any calculations there. Since those are not equal, this would be an example where they are not independent, which makes sense in this situation because I have different probabilities based on whether I studied or not, but I still need to prove that using numbers. If I did it the other way, the probability that I studied, so there's a 70% chance I studied, and then we had found the probability of studying giving an A already, so that was 0.42 over 0.57. I've lost some room. 0.42 over 0.57, which I can almost guarantee is not going to be equal to each other. Actually, I know it's not because it didn't work in the other direction. I get 0.7 does not equal 0.74. And these numbers need to be identical in order for us to say that they are independent. So hopefully that helps a little bit with creating a tree diagram and finding different probabilities using the tree diagram.